Hi everyone. Welcome to the Geeky Minds, your source for things related to system design and back-end development. If you are new here, I'm Gaurav, a back-end developer and your new friend in the tech world. Let's explore and learn about system design and back-end development together. Don't forget to check out my blog, https://thegeekyminds.com for even more great content. And please don't forget to like, comment, and most importantly, subscribe, so we can continue this amazing journey together. So grab a cup of coffee, kick back, and let's get started. Computing and microservices? It's essential for companies to stay on top of the most recent advancements in the fast-paced and constantly changing technology, in order to maintain their competitiveness. Cloud computing is one such technology that has experienced substantial growth in recent years. It has completely changed how businesses store, handle, and use data, enabling them to scale effectively and respond to shifting demands. Both cloud computing and software development's architectural frameworks are always changing. Microservices, which involve disassembling complicated programs into more manageable, autonomous parts, are gaining popularity because they have several advantages. What function does cloud computing serve in microservices, then? In this video, we'll examine how cloud computing enables the creation and implementation of microservices and how it might assist businesses in more successfully achieving their objectives. Let's dive right in. A software architectural style known as microservices divides an application's codebase into a number of smaller, autonomous services. These services can be developed, deployed, and managed individually, providing greater flexibility, scalability, and shorter development cycles. They communicate using protocols like HTTP. Advantages of microservices. Scalability. By scaling individual components, microservices can handle a large amount of traffic. Resilience. Microservices can be fault tolerant and can keep working even if one of their components malfunctions. Flexibility. Because microservices can be created, deployed, and managed individually, adding new functionality is simpler. Independent deployment. Teams can work on different system components at the same time and deploy them independently without affecting the other system components. Challenges faced in microservices. Complexity. Microservices increase the architecture's complexity, which makes it challenging to manage and monitor. Operational overhead. Compared to a monolithic architecture, managing and deploying microservices requires more resources. Latency. Performance can be impacted by a delay, which can be added to the system by inter-microservice communication. Inter-service communication. Microservices must communicate with one another, which can cause dependencies and integration problems. Understanding cloud computing. Cloud computing is like a big neighborhood library. Imagine you have a library card and can borrow any book you want, anytime you want, without having to keep all the books at your own house. Similar to this, cloud computing allows you to use computer services like data storage and design implementation through the internet without having to own every piece of computer hardware and software. And just like how different books are organized in different sections of the library, different services are organized into different types of cloud computing, like SaaS, IaaS, PaaS. Cloud computing is a technology that enables the delivery of computing services, including servers, storage, databases, networking, software, analytics, and intelligence, over the internet, the cloud. You can access these resources on remote servers on the internet in place of using your computer's hard drive and RAM to store and run the software. Advantages of cloud computing. Scalability, the ability to add or remove resources as necessary. Accessibility, any device with an internet connection can remotely access data and applications. Flexibility, the capacity to combine and pair services as required, in order to accommodate various workloads. Disaster recovery is also another benefit where you can quickly restore data and applications in the case of a catastrophe. The role of cloud computing and microservices. Cloud computing plays a crucial role in the implementation of microservices architecture. Here are the main ways in which cloud computing supports microservices. Infrastructure. Cloud service providers provide scalable, adaptable infrastructure. Deployment and management. By making it simple to deploy, manage, and grow microservices on cloud platforms, developers are relieved of the burden of handling infrastructure. Cost effectiveness. Businesses can lower their expenditures for infrastructure and operations by utilizing the scale benefits offered by cloud providers. Availability and reliability. Cloud providers provide highly available and dependable services, including automatic failover and disaster recovery, to fulfill the requirements of microservices. Integration with third-party services. Thanks to the cloud, it's simple to connect microservices to a variety of third-party tools, like databases, analytics platforms, and monitoring software. Hybrid deployments. Organizations can run microservices in both cloud and on-premise environments thanks to cloud computing. It gives us the freedom to select the best deployment strategy for each service. Examples of cloud services for microservices. Here are some examples of cloud services that are commonly used to support microservices. Amazon Web Services, AWS, a popular cloud computing platform. Amazon Web Services, AWS, provides a variety of services, such as computing power, storage, and database administration. Google Cloud Platform, GCP, a cloud computing platform that provides a variety of services, such as computation, storage, and networking, is the Google Cloud Platform, GCP. Microsoft Azure is a platform for cloud computing that provides a variety of services, such as computation, storage, and networking, in addition to AI and machine learning capabilities. Kubernetes, an open-source technology called Kubernetes, is used to launch, scale, and manage containerized applications automatically. Docker, an open-source platform for creating, distributing, and running applications inside containers. Spring Cloud, developed on top of Spring Boot, Spring Cloud is an open-source microservices framework for Java-based applications. Istio, an open-source technology for controlling communication between microservices and managing their management. The numerous cloud services that can be used to support microservices are just a few examples. The particular cloud service or set of cloud services that are suitable for a certain firm will rely on the demands, objectives, and financial constraints of that organization. Some of the difficulties in putting into practice microservices on the cloud are complexity. Setting up and managing a cloud environment that supports this architecture might be difficult. Scalability. In order for microservices to scale dynamically and seamlessly, the cloud provider must be able to withstand traffic spikes. Inter-service communication. In order for transactions to be completed, microservices must communicate with one another. This calls for a reliable and scalable communication infrastructure. Testing. A well-designed testing infrastructure is necessary because testing microservices can be challenging, especially when they are deployed in the cloud. Security. In the cloud, security is a crucial concern, and it might be difficult to safeguard microservices that have been deployed there. Monitoring. Keeping track of the performance of microservices in the cloud can be difficult, and specialized tools are needed. Cost. Putting microservices on the cloud can be expensive, so it's important to manage costs carefully to prevent going overboard. In conclusion, organizations wishing to modernize their software architecture in today's fast-paced technological landscape must consider using of cloud computing and microservices. Microservices can be developed, deployed, and maintained more efficiently with cloud-based storage, computational capacity, and scalability, resulting in improved user experiences. Several advantages of cloud computing and microservices include greater security and stability as well as the capacity to handle enormous volumes of data and variable demand. In conclusion, combining cloud computing and microservices is a strong tool for businesses trying to stay competitive in the digital era. And that's a wrap. Hi, I am Gourav Dhar, a software developer, and I create content on back-end development and system design. Subscribe to my newsletter and learn something new every week.